Hello and welcome to Otten Math. In this edition of Otten Math, we're going to go beyond CPCTC. We're going to talk about corresponding parts of congruent triangles and include that as part of our problem-solving effort. But then we're also going to include discussion on altitudes, radii, and overlapping triangles. Okay, in the first problem, number 13, we're given that triangle ABC is a triangle, and we're given two of the coordinates, A at -2,6 and B at 8,6. And we're also given that the altitude from C to AB is going to be 5, where C is a point that's located somewhere, and we're asked to find out where that somewhere is. Now, if we go back to our definition of an altitude, you're going to remember that an altitude of a triangle, it's a line segment drawn from any vertex. So in this case, the vertex is going to be C of the triangle to the opposite side, and the opposite side is going to be AB. And we can extend AB in either direction if we want. So we can take AB and we can extend it out to the right if we want. And we can also extend it to the left. So the altitude to AB doesn't necessarily have to connect with the segment AB, but it has to touch the line that extends in either direction from AB. So an altitude of a triangle is a line segment drawn from any vertex of the triangle to the opposite side, and we can extend if necessary, and it's perpendicular to that side, so it forms a right angle. So there are two different possibilities. One is where I have y equal to 11, and that's where C is going to be, because I can create any point on y is equal to 11 that ends up being perpendicular to AB. And again, remember, it can be on the extension of AB, and I know I'm not drawing these lines very well. But from y is equal to 11, I can draw an infinite number of perpendicular lines from y is equal to 11 to AB, or to the extension of AB as a line. In the same fashion, so C would be located on y is equal to 11. In the same fashion, I can draw from any point on y is equal to 1 an altitude to AB. Oops. Even if the altitude connects with the extension of AB again. So we can see that y is equal to 1 and y is equal to 11 will be the solution for the point C. So C can be any value of x. So C will be just any value of x, and then it will be either 5 or it will be 11. Okay, in the next question, we're given a circle O and a circle P. We're given that the perimeter of triangle AOP is 80. We're given that OC plus DP is equal to 16, and that CD is 2 units longer than OC. And we're asked to find OB plus BP. Well, what we're going to do is we're going to define OC as x. We know we're given, right, CD is 2 units longer than OC, so I'm going to say CD is going to be 2 plus x. So I know that OC is, I'll define as x. I know that CD is going to be 2 units longer than x, so I can say that CD is 2 plus x. And then I know that DP is going to be, OC plus DP is 16. So I know that if OC is x, then DP is going to be 16 minus x. All right, so I have OC at x, CD at 2 plus x. Well, now I have everything that I need in order to figure out what the length of each of the radii are based on the value of x. Because I know that OD is just the same as AO. They're both the radii of circle O. So AO, OD are the same. So I'm going to say that this is going to be 2x plus 2. So again, it's OC plus CD is equal to OD, and OD is the same length as OA. So OA is going to be 2x plus 2. The same way I can say that CD plus DP is equal to CP, which is the radius of circle P. And AP is also a radius of circle P. So I can say that CP is equal to AP, and CP is 2 plus x plus 16 minus x, which is just 18. So now I have everything that I need in order to figure out what the perimeter of triangle AOP is based on x, determine what x is, and then figure out what OB plus BP is. All right, so I know that OP is going to be x plus 2 plus x. That's 2x plus 2 minus x. So I have 2x plus 2 minus x plus 16. And that gives me x plus 18. So I'm just going to write that up here, x plus 18. So I have 2x minus x, which is x, and plus 2 plus 16 is 18. So I'm going to erase this first part. And that's going to be equal to OP. Then I have OA, which is equal to 2x plus 2. And then I have AP, which is just equal to 18. So I end up with 3x plus 38, and I know that that is equal to the perimeter AOP. So I have OP plus OA plus AP, that equals 3x plus 38, and it also is equal to 80. So 3x plus 38 equal to 80, 3x then is equal to 42, x now is equal to 14. So if x is equal to 14, I can find out what OB is. OB is going to be the same as OA, which is 2x plus 2. So 2x, 28, plus 2, OB is equal to 2x plus 2, right? Because all radii of a circle are congruent. And that is equal to 2 times 14 plus 2, which is equal to 30. Then I know that BP is congruent to AP because AP and BP are radii of the same circle. So BP is also equal to 18. I know BP is 18, so the sum of those two will be 48. Okay, last question. Two-column proof. We're given that AB is congruent to AC. We're also given that DB is congruent to CE. And so I've marked that up in the proof and in the diagram. So again, remember to draw the diagram, mark up what's given, then figure out beforehand how you're going to make this proof work out to prove that angle 1 is congruent to angle 2. I've got AB congruent to AC, BD congruent to CE. So let's go to the proof. Right, so I take the given AB is congruent to AC, BD congruent to CE, and I say A plus B, or AB plus BD, which is this entire length, AB plus BD is going to be congruent to AC plus CE, because if I add congruent angles to congruent angles, their sums will be congruent. Okay, so now I have AD congruent to AE, and in fact, let's just leave those marks there. AD congruent to AE. And then I know that angle A is congruent to itself. So angle A is congruent to itself by the reflexive property. Now I can say that triangle DAC, so DAC is congruent to EAB by side angle side. I have a side here, I have my angle here, and then I have a side here. I have a side here, my angle again, and then the side here. Because of that, because these two angles are congruent, I then know that DC is congruent to EB or to BE. I know that by CPCTC. I also know that BC is going to be congruent to itself, so this piece will be congruent to itself. And I was given at the beginning that DB and CE are congruent. So now I have two triangles again, DBC. So DBC, this triangle, is going to be congruent to ECB by side, side, side. I have a side, reflexive property, side, CPCTC. I have two triangles that are congruent. Okay, now I've established these the congruence of the two triangles. And I can say that angle DBC is going to be congruent to angle BCE by CPCTC. So I've established the congruence of these two triangles. I know that angle DBC and ECB are going to be congruent. Then I know that angle 1 and angle 2 are going to be congruent, because if I have two angles that are supplementary to two congruent angles, DBC and ECB, then those angles are congruent themselves.